In this video, we'll be looking at changing the d value of our trig functions, and we have the same setup as the previous videos. So looking again, we know that we're just changing the d, so y is equal to sine x plus d, y is equal to cosine x plus d, and y is equal to tangent x plus d in this video. So without further ado, let's go and let's see what happens. Now, one thing I want you to have a look at first, I'm just going to draw in y is equal to 0. I haven't done this in any previous video, but I just want to, oh, that doesn't look very nice. I just want to highlight that point there. This is the line that I talked about before, I didn't draw it, that oscillates around, okay? So can we see here, it seems to just oscillate around this y is equal to 0 line. So let's just park that in your mind, and now we'll look at some transformation. So let's go y is equal to sine of x, and maybe we could just add d and see what happens with the slider to begin with. So we can see here that the graph seems to go up and then down, and up and down. When it's negative, it's going down. When it's positive, it's going up. And when it's 0, it doesn't change. Now, we know this because d is our translation up or down. If d is positive, it moves up by that many units, right? So here, if d is 2, let's have a look. It's 0 and it's gone to 2. So all our y values are getting 2 added to it. So if I was at originally 0, 0, our key point, it goes to now 0, 2. What about our key point here, 90 degrees 1? Well, that's going to add 2 to the y value, so it should be 90 degrees 3, for instance. So that seemed to work pretty well. Okay, so what I'm going to do now is I'm just going to get rid of that and add the 2. Now, what do you think happens to this line y is equal to 0? Well, if we're translating this graph up, it goes to show that also the y is equal to 0 will translate up too. So y is equal to 0 plus 0 plus 2. I can't draw a 0. I don't know why. Huh. Okay, that's weird. 0 plus 2, which is 2, right? Hey, that looks relatively familiar. It looks like the y is equal to 0 has just moved up 2. So we can see here, and I might change it to purple to show that, we can see that's just oscillating around that line. And that can help us with sketching as well. Okay, so what's happening? All our y values get increased by 2. We're going to move to cosine now. Y is equal to cosine, and let's move this thing down. How can we move it down? Well, we saw if we made d a negative value, it would go down. And let's go take 3.5, for instance. So what's going to happen to all our key points for the... Whoop, damn. What's going to happen to our key points for cosine x? Well, they're all going to move down. The y value is going to move down by 3.5. So that means if I just pick one at random, we already know 0, 1 is a key point. The 1 is going to have negative 3.5 to it. It's going to move down negative 3.5. So it's going to be negative 2.5. Brilliant. Seems to work. And let's look at another key point. I do know that we've got negative 90 is 0, and that should be now negative 90 2.5. And it's probably a bit harder to find. 3.5, sorry. So we can see that every y value is shifted down 3.5, and therefore the effect is the entire graph is just pushed down. Well, where should that y is equal to 0 thing go to now? Well, it should be negative 3.5, and we can see there it's oscillating around it nicely. And I use the word oscillate, I'm not even sure that's correct, but I just like using it. Sounds fancy. Now we're going to look at the last one, tangent x, okay? And let's just look at some graphs. Let's go y is equal to tan x plus, I'm not very imaginative, 1. There we go. And we're just going to change the color to orange. No, we're not. That looks terrible. Blue. Yes, blue's better. So all our y values, guess what's going to happen? You're going to get 1 added to it. So let's look at our key values. We know 0, 0 is going to go to 0, 1. Hey, it worked. We can see that our asymptotes aren't going to change because you're just moving x is equal to 90 degrees up 1. That doesn't change the shape of this line at all. Okay, it's still x is equal to 90 degrees, and our 45 degree, one of our key ones, is now going to go to, and hopefully there we go, 45 degree 2. Let's label it so we can highlight it later when I take a screenshot. There we go. So what we've done is we've looked at sine, cosine and tangent all for a translation D up and down units.